Okay, fine. So what exactly is SciPy? See, SciPy means SciPy is the a scientific library. See, it is a scientific library for Python. Okay, and it's an open source. The major thing what you have to look into is actually this is an open source. See, what are the things which we can do under this actually? See, when you have this particular scientific environment means actually we can do all science, mathematics, engineering. So let me call that. So what all we can do under this? So all your mathematical problems, mathematics, science, and engineering. Okay, so I'm trying to put these three. See, you have other things also, but these three things can be done extensively under this SciPy library. It's a scientific library used for mathematics, science, and engineering. Okay, now the SciPy library, this particular thing depends on what are the things we have actually. Here, the first and the foremost library what we will be using is one by one I will list down. It is the Numpy. Okay, what is this Numpy? Which is the which is for the n dimensional. See, this Numpy used for mathematics using an array environment. Okay, so that means so the SciPy library depends on, so I can call it as depends on Numpy, which means which provides a convenient way of doing your mathematical calculations using a dimensional array system or matrices. Okay, here I'm going to use what is called as n dimensional. I'm going to call it as n dimensional array system for your calculations. Okay, for calculations. If I use that, it becomes your Numpy. Okay, all comes under, see, based on, see, it is, see, overall what I can call this as an n-dimensional, or it's an array package. Okay, it's a n-dimensional array package. That's what I can call it as. So it is based on n dimension. It's an array package. So it's an array system, or a few books they call this as a package. Okay. Now, see, what is the main reason for having this SciPy library? So when I have a SciPy library, this library issue, whatever this particular library have, though, this particular SciPy library, this library should be able to work with your arrays what I have created. See, this is the first thing. And these arrays what I have created or for mathematical operations should be two things. So whatever I'm going to create, they should be user friendly. Whenever I write use a package, they should be user friendly and efficient. Otherwise, why I'm going to use this package? I won't use it. See, and efficient, and that, see, this is a numerical thing what I am trying to use. It's a numerical. See, what are the things which we try to, when I try to use an array, and what are the simple things what we try to do actually. So whenever I speak of your MATLAB or your Python or any kind of Octave and all, what we try to do, we try to do numerical analysis. Am I right? So it is numerical analysis. So it may be numerical differentiation or numerical integration, differentiation, or it can be numerical integration, whatever it may be. Fine. And what I'm going to do actually, I use this package to optimize many things. That means optimization of any given problem statement or something should be able to done using your Numpy through SciPy library. Okay, now one particular thing. These are something like modules. These are something like a modules. Now, when I speak of this particular thing, so what is it actually? SciPy. So some of the books actually. So they tell this as SciPy. So that's SciPy. Okay. Now, see, it's something, but there are some packages. See, under SciPy, lot of packages are there. Okay, what you have to do actually, if I want to use the sub packages, see under this, see if I try to install, so sudo apt install SciPy or pip 3 or pip, if the pip install SciPy, there are some sub packages which get installed in your local system. Okay, so those things we'll try to look. So SciPy packages. Okay. What are this actually? SciPy, I think some books they call this as SciPy sub-packages. So rather than simply this thing, SciPy itself is a package. Let me call that as sub-packages. Okay. Now, these sub-packages are used for scientific computing. So sub-packages are used for scientific computing. What I call it as scientific computing. So I will try to summarize a few, so which may be used actually. Maybe a few things you can just, so I may list around 5 to 10, so which is very extensively used. Okay, say for example, if I try SciPy dot constants. Okay, SciPy dot constants. So it means that it is going to use all your physical and mathematical constants. Mathematical constants. So under the SciPy sub-package, all those things are there. Suppose I want to use the Fourier transform. Okay, then what I use actually, I'm going to call SciPy dot, okay, FFT pack, PACK. If I use this particular sub package is used for Fourier transforms. Whenever I want to do some kind of Fourier transform equations, I can use. Say I want to do some integration of a given equation. So what I'm going to do actually, I'm going to use a package SciPy dot integrate. If I use that, this is used for integration of equation. Say I want to do some kind of an input and output parameters. So I want to input data input and data output. So in that case, what I'm going to use actually, this will be SciPy dot IO, that is data input and output. Say I want to do some kind of an interpolation. Okay, I want to do some kind of an interpolation. So what is this interpolation if I want to do? So I'm going to use this one, that is SciPy dot interpolate. If I use this particular package, I can use for interpolation. This is one of the package. Say I want to use for linear algebra. So some of the linear algebra is there. So I have a SciPy sub-library for that. SciPy dot linalg. That is, this is used for linear algebra. Linear algebra. Say I want to use for some kind of an optimization of a given problem. So in that case, what I am going to use? SciPy dot optimize. Okay, this is used for optimization. So sometimes I think if you are an electronic student and all, I want to process on some kind of an signal processing. Okay, so I have a package for that also. SciPy dot signal. That means that is used for signal processing. Say I want to work on some kind of a statistics. Okay, some kind of a statistics actually. So I can write SciPy dot stats. So this is extensively used for statistics. So like this, I have a number of packages. Say for example, some kind of a I want to build some kind of a structures of algorithms and all. So we use something called as a spatial. Say I want to use for some kind of special mathematical functions and all. So So I use SciPy.special and all. So there are n number of things I told. So there are n number of things which say I want to use some kind of an regression problems. So maybe some kind of an orthogonal regression problems. So there is a package called as SciPy.odr. Okay, I can use whatever the package, I use that particular sub package for that particular option or particular condition I'm going to use it actually. So now, so yes, for example, I want to insert at any given point, I want to install your pandas or SciPy, all those things. What I told, you have to go with either pip or sudo. So some of the things sometimes it may work. So if I'm using if I'm using the different platform, OS platform, whether it is a Windows or Linux or Ubuntu, just go there and you can install. So what are the platform? So I'll give the website. You can just go to scipy.org actually. You can just go to this. So this particular thing, scipy.org. So just go to this particular install platform. I think there's an install web page is there. Just go there. So whatever the platform you have, that particular platform you can use. So I'm using my Ubuntu platform. So the option is actually sudo apt install python -numpy or python maybe SciPy or python -matplotlib. So all those things I can use it, or python -pandas. Sudo apt if I use, I will get for the Ubuntu. If you're using your maybe Mac OS, so Mac OS you have to use the pip command. So pip command you have to pip. I think you have to go to that particular environment. You have to check for the pip option which is used. So pip install SciPy, pip install pandas, or pip install numpy. So you have to use that and you should be able to get it. So whenever you're using this particular SciPy, whatever it may be, so maybe one by one I told, see, we have n number of environments. So you have lot of environments under your SciPy. Which environment I need to use it actually? It's one particular thing which always comes under your mind. See, SciPy library, I told it's a fundamental or a basic library for all your mathematical science and engineering, or we call it as scientific computing. So I want to use only for math dimension. So if I want to use for mathematical operations, so using some kind of a dimensional thing, I'm going to use NumPy. So I want to use for plotting. So I want to use for plotting. What I need to use, if it is I want to go do some kind of a package for only for plotting. Okay, we have a package which is called as matplotlib. Okay, now if I want to use only for symbolic mathematics, so I think if you guys in fourth sem we use something called in the MATLAB, we use what is called sim command, sims actually we use, that is we have for symbolic, that is for your symbolic mathematics. Symbolic mathematics, if I want to use it, mathematics, I have a package what are called as sympy, so symbolic Python. So I want to work on some kind of a data structures and analytics. Okay, so some kind of data structures and its analytics. Data structure and analytics. If this is what I am looking at, I will install what is called as pandas. So if you look at your what is there, so these are some of the packages what I'm going to use. So if I want to use some kind of an interactive console, I think just like your idle or maybe your Python interactive kind of a thing. If I want to use interactive console, I think we try to go with what is called as IPython. Okay, each and every packages what we try to use, those things we'll try to use, install and try to use it. Okay, all are your open source environments. So that we have to keep in our mind. Each and every environment what they are using, they are all open source. This not, you can't call it as free, you will call it as it's a open source. Okay, now see by default, see, if for example, if I have a SciPy, if I have installed a SciPy and all, there are, I think, some of the earlier Python this thing and all. If Python is installed, okay, some of the Numpy functions are installed or will work explicitly. See, if SciPy is imported, the meaning is maybe it doesn't work, most of the things it won't work. So if I try to install or import SciPy, NumPy functions should work explicitly. Okay, because so what I told, what I want me to tell is actually NumPy is a multi-dimensional array functions or array element. Okay, let me give a simple example. What is this actually? Say for example, if I want to write some kind of a program, so I am writing a program and try to create it. Say for example, let's take an example of NumPy itself. So let's take an example of NumPy. Usually when you are using this thing, actually, what we have to use, I think, hope you remember that we used to use Sims actually, Sims A, B, C or something. If I want to write an equation, quadratic equation, y is equal to ax square plus bx plus c. Okay, if I want to use this actually, what we used to define in our symbolic mathematics in MATLAB, we used to put SYMS, A, B, C and X. So all the parameters we used to define, then whatever we used to write, we used to get the symbolic mathematics. In a similar fashion here, I want to do some kind of an array thing. What I'm going to do actually, I'm going to import NumPy, N-U-N-P-Y, or maybe as NP. So I'm going to usually NumPy is imported as NP, So NumPy is imported as NP. Then I'm going to define some kind of a thing. Let me call that as some matrix. Let me call it as some mat. So let me some 4 elements. Let me call it as some 1, 3, 5, 7. I have imported it. Now, what is it actually? Let me call this as, this is a list actually. This is a list of elements or what I am trying to call. This is a list actually. Now, if I want to create some kind of an array of it actually, what I want to do is actually, let me call this as some ARR, something like that. So instead of NumPy, I'm going to call this as NP and I'm going to use the array function. Okay, array function of this mat. So what I'm trying to create here actually, I am trying to create an array or matrix. Okay, I am going to create a matrix using your NumPy. So if I try to print it, so if I try to print ARR, see if it is Python 2.7, if I am using Python to print, you need not put the bracket. Print with simply I can write ARR. So Python 3, I have to put the bracket. So what will be the output? So if I do this particular thing, I am going to get an output as 1, 3, 5, 7. So this is my output. Okay, what is it actually? I am trying to see. It is nothing but I am trying to create a matrix. I am trying to create a matrix 1, 3, 5, 7 and trying to print it. Say for example, I want to create a matrix of zeros or null matrix. So what should I have? Say there are some built-in functions are there. So say one more example. Say I want to create or I want to have some kind of a null matrix. So what will be the program? It will be simply import NumPy as NP. Okay, print. So directly I'm going to with the actually print or NP dot zeros. Okay, zeros. I can go with whatever the matrix I want. Let it be 2, 3 means it will be 2 rows and 3 columns. Okay, so I'm going to get this particular thing. So now when I have this particular thing, what will be the output? Output will be something like, the output will be, it will be array, okay, and it's going to tell that it is zeros, okay, and then it's going to show the So this will be 0, comma 0, comma 0. Then I have comma 0, comma 0, comma 0. So this is what will be my output. So this is my output. Because zeros is an inbuilt function for null matrix. So instead of zeros, if I put ONES, what I'm going to get actually? I'm going to get the your unit matrix, that is 1, 1, 1. So once that particular thing, if I use actually, will create an array filled with 1 values. So zeros means it's a null matrix. Okay. Now, so there are different things are there. Say for example, you have in Numpy we have so one function called as arrange. Okay. So I can create that, use that arrange function to create an array to increment in a regular fashion. So usually it starts with 0. Say in this particular, instead of zeros here, let me tell that also. So instead of that, actually, if I use np dot arrange, okay, instead of that particular thing, let me instead of this particular thing, instead of this particular line. So if I use print dot, okay, so print np dot arrange, okay, 6, okay, arrange 6. So what does it do? What will be the output? So it gives an output, okay, array, okay. This output will be, it starts with 0, 1, 2, 3, 4, 5, okay. Because 6, I'm trying to give 6 elements. It is 1, 2, 3, 4, 5, 6. So above program, whatever the simple program, what I have written, import numpy as np, print arrange, I'm going to use arrange function, will create an arrays with a regularly incrementing values. What is an increment actually? It is 1. Okay. Now you can have different data types. You can have float, you can have whatever it may be. Okay. So you can have the linspace also. Just like your linspace, what we did use actually, maybe in our MATLAB, what we use, linspace. So import numpy as np, print np dot linspace. So you have your starting point, you have your increment point, and you have your end point actually. So you have starting point, end point, and increment, or number of things what I want actually. So I can use the same thing. So I can use, so if I have one more example using your linspace. So let me, the first thing is import numpy as np. So maybe np dot lins space, okay. So that particular thing, if I try to do, so linspace, or maybe linspace. So what will be the starting number? Let it be some 1. Linspace, let the starting number be some 1, okay. So ending number be some 6. So how many numbers I want? Maybe I want some 8 points. Okay, what will be the output actually? This will be, I'm going to get an output array, okay, with starting number is 1 and ending number is 6. In between I will have 8 points, okay. So what are the points actually? It will be 0.75, okay, 0.75, 1.5, okay. So I'll get all those things. 0.75 plus 0.75, I'm going to get actually. So each and everything, it will get incremented. Okay, 1.5, then 2.25, then 3, like that I'm going to get till I'm going to get the, so 4 points here, 4 here. So I'm going to get 8 is good. The whole thing gets divided by 8 points. Say I want to create a 2 by 2 matrix. So 2 by 2 matrix if I want to. So if I want to create a 2 by 2 matrix, say example, so let me take that, or 3 by 3 matrix, whatever it may be, 2 by 2 or 3 by 3, whatever it may be. So the first thing is this, whenever I'm using this package, Numpy, import numpy as np should be your default line. First line should be default. Whenever using this package, it should be your default. Then, what should I do actually? I should go and what I want to do actually here, I want to have, say for example, so it is np dot, so for that it is the, whatever the function I'm going to use is your matrix. Say the matrix is, say for example, I can give the values there itself. I need not go. So I can give a matrix, say for example, 1, 4, okay, semicolon, maybe 6, 8. So I'm trying to create a 2 by 2 matrix. Or if I want to create a 3 by 3 matrix, I can go 1, 4, 8, semicolon, 8, 5, 7, something like that, whatever I'm trying to do. So what will be the output? The output will be the matrix, okay, the matrix created in the particular fashion, 1, 2, 2, 3, 4, okay, so all are in square bracket. This will be your output. Okay, if I want to do a transpose of the particular matrix, so that also we can do that. So I can do, so transpose of the matrix, if I can do that. So if I want to do that transpose of it, so what I'm going to do, what I need to do actually, so let's say for example, if I want to do a transpose, so what I will do, this I need to define it actually. Let me call this as some ARR, okay, ARR. So what I'm going to do, if I want to do a transpose, so what I will do actually, dot T, okay, dot T. So if I want to do a transpose, so transpose of a matrix, what I am going to use, ARR dot T will give the transpose of the matrix. So what I'm going to get in that case, the output will be 1, 3, okay, and you have here, say for example, 2, 4. This will be your transpose of your matrix. So your columns will become rows, rows will become columns. So when we transpose, what we are trying to do, we are trying to do rows to columns, columns to rows. So these simple operations can be used or can be done using your simple Numpy packages. Okay, so Numpy is what? You can do many operations actually. So maybe what I am showing is all very basic fundamental operations. So basic fundamental operations can be used or can be done using your Numpy. So Numpy packages, you just use that and try to get it. Fine. So we'll stop here. So if there are any questions, I'm ready to take them.